Your mind is about to be blown, because black holes, which lurk in the cosmic abyss like intriguing mysteries demanding to be solved, have captured our imaginations for eons. Yes, the revolutionary James Webb Telescope has finally seen what is inside a black hole. It's true that the remarkable journey reveals the long-hidden secrets contained in these celestial mysteries. Astronomers were taken by the results the James Webb Space Telescope brought back when it was first designed towards the ultimate frontier. This increased the faith of scientists and numerous research teams in the telescope's great resolution and high sensitivity. As a result, it was put to use for more missions, including revisiting older missions or observations made by earlier telescopes. Every time the James Webb Telescope looked into space, its powerful optics awed the scientific community. However, until the James Webb Telescope was told to look inside a black hole, it had been all a fun, thrilling journey of awesome findings. The entire adventure began with the James Webb Space Telescope's finding of the oldest black hole in our universe. This scary phenomena, which is a cosmic giant said to be 10 million times more massive than the Sun, was discovered by astronomers to their great joy. 570 million years after the universe's inception, the James Webb Space Telescope, which has strong cameras that enable it to peek into the last frontier that dates all the way back to the very early phases of the cosmos, discovered the supermassive black hole at the center of a newborn galaxy. Several black holes that grow to unfathomably large sizes at the cosmic dawn have been theorized and speculated to be the source of the monster since its discovery. Approximately 100 million years after the Big Bang, when the cosmos was still expanding and had a billion years to shine, this epoch started. Huge black holes are prevalent in the universe, but astronomers and physicists are unsure of how or why this is so. According to Rebecca Larson, an astrophysicist at the University of Texas, we do anticipate that this black hole did not suddenly arise. Therefore, the universe should contain more than just younger and older. We're only now beginning to investigate this period of cosmic history, she claimed. Black holes are created when massive stars collide, and they then start to eat gas, stars, dust, and other black holes to continue to develop. In the case of some hungry space-time ruptures, the friction drove the material to spiral into their moors to heat up, and they released light that could be detected by telescopes, converting them into so-called active collecting nuclei, AGN. Quasars, which are supermassive black holes 1 million times as big as the Sun and expel their gaseous cocoons with a light burst that is much brighter than the brightest stars, are the most extreme AGN. Since light travels across space at a constant speed, the further into the cosmos scientists and astronomers go, the more distant light they cut off and the farther into the past they can view. So, using the mid-infrared instrument and near-infrared camera of the James Webb Telescope, researchers and astronomers scanned the sky in search of the black hole. They also dissected the light into its constituent frequencies using spectrographs built into the camera. Scientists and astronomers detected an unusual spike in the frequencies present in the light after dissecting the flimsy glimmers transmitted from the universe. This was a crucial sign that the hot material around a black hole was beaming out slight traces of radiation across the universe. This gave a thought on how black holes came to spread across our young cosmos, making it a mystery. Now, there are numerous groups of astronomers and scientists who are constantly searching for younger and suspected primordial black holes, which are thought to have originated prior to the Big Bang. However, they have so far eluded researchers, who were forced to collaborate with the group that created the mid-infrared equipment to look for a stronger signature of light from a distant galaxy. Yes, they performed this to see if they could learn more about how the peculiar black hole at the core of our universe was created and to see if they could make any new discoveries. On the other side, another team persisted in using the James Webb Telescope to discover more information about black holes, particularly supermassive ones. After discovering the oldest black hole in the cosmos, the James Webb Space Telescope has now discovered another supermassive black hole that contains elements that astronomers and scientists never anticipated. James Webb Telescope finally sees what's inside a black hole. The center of 3 active galaxies was discovered to have a carbon-containing compound known as polycyclic aromatic hydrocarbons (PA) by the most powerful telescope in the world. Scientists were perplexed not only by the discovery of these carbon-containing molecules, but also by their discovery of the place in which they were found. These carbon-containing compounds were found in places where scientists didn't think they could exist. Additionally, studies from the molecules revealed that the supermassive black holes in these galaxies surrounding radiation drastically altered the compositions of the PAHs. Now, this might make it more difficult to compute star formation, which could limit the utilization of stars as biological building blocks. 3 active galaxies were observed by the mid-infrared sensor on the James Webb Space Telescope, and the observations were examined by a group of astronomers. The 3 galaxies are NGC 6552, NGC 7319, and the well-known Stephan's Quintet, which are all located in Pegasus, about 311 million light-years apart. NGC 7469 is also located in Pegasus, although it is about 200 million light-years away. The compounds known as PAHs are made up of rings of carbon atoms. These rings of carbon atoms are widely distributed across the universe, from comets in our own solar system to far-off galaxies. Because of their pervasiveness, they serve as both crucial traces for the development of stars and fundamental building elements for life. When exposed to ultraviolet, UV radiation and starlight, PAHs emit significantly at infrared wavelengths, which MIRI can detect. Therefore, whenever astronomers and scientists discover PAH in this manner, young hot stars are undoubtedly close by. Now, all PAH molecules would be destroyed by a supermassive black hole at the center of an active galaxy. The core regions of all 3 of the observed galaxies had more paths, according to observation. However, it was eventually discovered that the emission originated from bigger, electrically neutral PA molecules, demonstrating that radiation had indeed destroyed smaller, electrically charged PAs. The larger PA molecules may have survived because, during the meeting, they were smothered by thick molecular gas clouds. Because they rely on these tiny electrically charged paths to detect evidence of star formation, astronomers are concerned about their disappearance. Speaking of evolution, astronomers and scientists were not happy with these results and continued to search for additional information that could explain certain events. One such phenomenon is the singularity at the heart of a black hole, which is the proverbial no man's land. The concept of space and time entirely disintegrates in this location as masses flatten into an infinite number of small points. But since the singularity doesn't actually exist, scientists had to come up with a replacement for the phenomenon that gave rise to so many potential outcomes. The first possibility was that instead of being squeezed to an infinitely small point inside a black hole, matter would instead exist in the smallest possible arrangement known as the smallest possible volume pocket. This possibility is called the Planck star, and it is a hypothetical possibility that suggested the concept of loop quantum gravity, which is itself a highly speculative idea for developing a quantum version of gravity. Space and time have quantized dimensions in the domain of loop quantum gravity. Although the universe is made up of little, distinct pieces, it is so small that our movement appears to be smooth and unbroken. Now, this hypothetical chunkiness of space-time has 2 advantages. First, it fulfills the ultimate goal of quantum physics, naturally explaining gravity, and second, it prevents singularities from forming inside black holes. The massive gravitational pull of a falling star encounters resistance as matter squeezes under. Matter cannot travel any further than the Planck length, which is 1.68 by 1035 meters, due to the discrete nature of spacetime. This results in the compression of every matter that has ever entered the black hole into a ball that is microscopic, but definitely not indefinitely small. It takes billions or perhaps trillions of years for a black hole to explode, despite the fact that they are merely transient things due to the enormous time dilation effects surrounding them from our perspective in the outer universe. Independent of unproven quantum gravity theories, the gravastar is another idea that contests the singularity theory. But a gravastar and a black hole differ from one another. Consequently, the distinction between a gravastar and a black hole is that the former is filled with dark energy, which expands spacetime rather than being a singularity dark energy. However, despite the fact that this idea can sound like something out of science fiction, dark energy is truly at work in the bigger cosmos, speeding up the expansion of the entire cosmos. Outside of that surface, gravastars appear and behave like regular black holes, but the event horizon of a black hole is a point beyond which nothing, not even light, can travel. Click on the subscribe button if you are finding this video interesting. As we continue to explore this phenomenon, physicists like Joseph Polchinski, Ahmed Almheri, Donald Meroff, and James Sully collaborated to develop the black hole firewall hypothesis, also known as the AMPS firewall. According to their calculations, the event horizon might potentially transform into a massive wall of fire, in which anything coming into touch would instantly catch fire. This implies that black holes have no escape because nothing can ever be visible. This defies Einstein's general theory of relativity, according to which a person or object would be in free form and not experience the intense effects of gravity in any way if they crossed the event horizon. According to the equivalence principle, neither a person nor an object would be in any kind of great hardship if they crossed the event horizon. What exactly do you think of these black holes right now? Do they provide insight to a location that astronomers and scientists are yet to find out? Want to know more about the findings of this mammoth of a spacecraft? Watch this video popping on the screen right now to learn more.